and a small group of Scottish islands that could teach scientists much more about the Ice Age, known as Snowball Earth.
Now, it's known as Snowball Earth, the longest and deepest ice age in our planet's history. Exactly how it came about has been a mystery, but a small group of Scottish islands may have just given some scientists maybe a key to understanding it.
The Garvellach Islands in the Inner Hebrides in the west of Scotland apparently offer the best geological record of the Earth's transition into an ice age 720 million years ago.
And those findings could open the door to a better understanding of why it happened, how it laid the groundwork for animal life to evolve. Our science correspondent, Pat Ghosh, has more.
These tiny islands in the Inner Hebrides of Scotland hold the key to how the first animal life emerged on Earth hundreds of millions of years ago. Each layer of this rock face in the Garvellachs captures a snapshot of the planet's distant past. Scientists have now dated fragments of the rock and shown them to be from the only place in the world to have a detailed record of how our planet plunged into the most severe and prolonged ice age in our history. These tiny grains prove beyond any doubt that the Garvellachs are the best and most complete record of a critical period in our history called Snowball Earth, when, for 80 million years, pretty much the entire planet was covered with ice. If we wind back the calendar hundreds of millions of years, we see that Scotland was in a completely different place because the continents have moved over time. It was south of the Earth's equator and had a tropical climate until it and the rest of the planet became engulfed in ice. But then something remarkable happened.
After the melting of the snowball, we suddenly start to get bona fide, modern-looking animals.
It seems counterintuitive that such a big freeze that could have prevented life was actually the spur to generate this explosion of life.
After the snowball melted, of course, everything that had adapted to that and diversified in those specialist niches would have had to then compete with each other in some kind of arms race.
Geologists have been studying the rocks on the Garvellachs for decades, first on foot, using the only building on the island as a base, and more recently using drones to create detailed computer-enhanced images of the rock layers. If the results are confirmed, these islands could be awarded a golden spike. That's an actual spike hammered in to celebrate the location of a planet-changing geological moment.
So tell me what you're doing, Elias. You're hammering in the golden spike.
Elias Rugen imagines what it might be like to receive one of science's greatest accolades.
It would be fantastic. Golden spikes around the world are reasonably big deals. The previous one that was ratified was some 30 years ago, so it doesn't happen that often.
Do you think you'll get it?
I'm hoping so. I think it's definitely the leading candidate. I don't think there's many other layers of rock and sections around the world that come close. So I'm quite confident, yeah.
These are the judges of the Golden Spike, a group of the world's leading geologists on the Scottish island, seeing for themselves what all the fuss is about. Among the most influential of them is the Secretary of the International Sub-Commission on the era.
Scotland can get the Golden Spike. The chance is very high, based on the Garvellach formation, presented a great example, excellent example of the potential candidates of the Golden Spike.
Researchers will find out next year whether they and Scotland have won the Golden Spike. But in the meantime, they press on with their research, studying the rocks that hold the key to the emergence of the first complex life on Earth. Pat Ghosh, BBC News.
I'm very pleased to say David Schultz, Professor of Meteorology at the University of Manchester, joins us now. Very good morning to you, David. I think you can start with some quite basic stuff for us about the notion of the Earth encased in ice, which probably people have an idea that that's how we were at one stage. How does all this that we're discovering help us with knowing more about that?
Right. Well, the Snowball Earth is such a foreign concept to us. We think about the climate of the Earth that we're in now, and we have these polar ice caps both in the North Pole and in the South Pole. And here we have to imagine that these ice caps have expanded all the way to the equator and covered the Earth, if not fully, mostly in snow and ice.
So this is a ball of ice with the Earth, as we know it, the rocks beneath.
That's right, that's right. So kilometers below, and these rocks here would have formed in the ocean underneath those.
Why would we have been covered in ice? What would have caused it?
Well,
because I can understand what's causing the ice caps to melt now, but what would have made us?
Yeah, so you have to imagine a very different kind of Earth. I mean, you wouldn't have seen any life, plant life on the surface, and as you heard in the segment, there was just single-celled organisms within the oceans themselves.
So it couldn't happen now.
No, we're a long way away. A lot of changes would have to happen in the Earth's climate system in order to get back to that. But yeah, I mean, this environment that they were in was totally different. The Earth would have been almost covered in ice, maybe just some gaps in the tropics, and what single-celled life existed at that time would have had to have lived under those harsh conditions. But that's not unusual relative to what we know now. We know in the Arctic, in the Antarctic, that life is existing in the deep oceans and underneath the ice sheets themselves.
Now, I'm not sure if you saw it in the film we saw a moment ago. There was rather a clever graphic which showed where Scotland was when the Earth part of the Earth, those land areas, were joined together. And that's an extraordinary thing, isn't it? Literally, it's so different from what we conceive of now.
Yeah, there are periods in geologic history where the continents, I mean, we know the continents move around on the surface of the Earth, but every once in a while, maybe every 200, 300 million years, they come together. And so you may be familiar with the period of the dinosaurs. There was a supercontinent, we call it, called Pangaea. Most of the continents, all the continents were joined together into a big C-shaped supercontinent that spanned both the northern and the southern hemisphere. Going back to this period, 700 million years ago, there was another supercontinent, and that started to break up at the time.
Are you absolutely certain? That 700...
Well, you have to talk to the scientists.
That 700 million years ago, for example, there was a supercontinent, or that, this Snowball Earth happened, because science is evolving all the time. And look at Stonehenge, just seen the heart stone, thinking it was from Scotland, thinking it was from Wales, and it's actually from Scotland. Things change all the time, and we absolutely think, we've got no proof.
We have evidence, right? I mean, this is how science progresses, as we go along, as we collect more observations in the Earth system, as we do computer modeling, which is what my group has done with Snowball Earth. That you get more and more pieces of evidence, and you can piece it all together. So, the evidence that there were ice sheets that covered most of the land masses at the time, we have those records, and we have, indirect evidence that there must have been ice there. And that's
I
how
suppose technology means that when you get a lump of rock taken from an amazing place like this in Scotland, for example, that could be anywhere around the world, couldn't it? You now can know more about it, presumably by how you analyse it.
That's absolutely right. So new technologies, new ways of analyzing it allow us to more precisely date these things, which is what these scientists did, get a more precise record of the timing of when ice came and went from this particular location.
It's fascinating work you do, isn't it?
It's fun.
It's kind of...
What's the most bizarre fact you can tell us really quickly that we can take away and say to someone in the pub or over coffee today?
From the modeling that my students and I have done, these snowball Earths can happen very quickly. So imagine both ice sheets from each pole expanding towards the equator, and then within 20 years, 30 years, boom, it closes up and the whole Earth then becomes encompassed in ice.
So once they're close, that's it. That's going to happen in 20 years. It's a while away.
It could, in that environment, in that particular time, it could happen that quickly. And then, of course, then the question is, how do you get out of a snowball Earth? Again, a very fascinating issue.
Sounds like a movie, doesn't it?
It could be a great movie.
David Schultz, Professor of Meteorology at the University of Manchester, thank you so much for joining us.
Welcome. Thank you.